Hello and welcome back to another episode by Bite-Size Security. It's your boy Jimmy, and today I'm bringing you another hacking video, and we are going to look into a HackTheBox machine called Fluffy. And so without further ado, let's just get straight to it. So as usual, I'm just going to go to the folder where I'm going to work out of and do prep nodes and then Fluffy. And that will create the nodes folder and the working directory out of which I work. And so inside of that, I'm just going to go into enumeration, external, and I'm just going to start my recon as I usually do. And I'm also going to run russcan just to get a quick idea of the ports that are ready or open rather. And then I'm just going to also open the working directory called Fluffy, just so that I have that on the side. That's a bit slow, but it's the first time it opens, and that's populating, as you can see. And let me just close all of this, close that, open that again. And then I'm also going to open Obsidian, as I always do, because that's where I'm going to take my notes. I just started the virtual machine, so everything is a bit slower. But while all of that is running, let me just give 2 minutes of explanation. So in my last video, I made at the beginning of a new playlist for Web3 hacking, but my path is taking me back towards Web2 stuff. And so I thought, what better to do than start getting back into the rhythm of things by doing a track which HackTheBox has created that prepares you essentially for the CPTS exam. CPTS being a certification by HackTheBox. Now, whether I do that certification or not is unclear for now, but it's definitely a good way for me to get back into the swing of things as I am a bit rusty. And so, yeah, I'll just go through each of these boxes one after the other, and the first one of these is Fluffy. So let's just go ahead with that. Let me put the IP here, and I have the russcan that's probably already ready. So I can just take this and paste it here, and from there we can see the different ports that are open. So definitely it's a Windows machine, so let me just close HTTPS because I can't see it here. And then we can start creating the other ones. So there's 53 DNS. Then there is an LDAP. Then there is WinRM, 5985 WinRM. Then there is those RPC. And then the bigger one is this one. RPC, and then what else do we have? We have a lot of LDAP, Kerberos, 88 Kerberos, and that's about it. You can delete this one, and then let's see if AutoRecon is already done. No. So what we can just do is just get straight to enumeration, right? And where are we going to do this? Let's go to loot, and let's create a folder for SMB. Let's create another folder for hashes, which might come up later. And let's go into the SMB one. And then here, by the way, we also have credentials that I've copied into my clipboards. By the way, this application is called Populate, if you like it. It allows you to have control over your clipboard and things that have been in the clipboard in the past, so it's very, very useful. And so these credentials I can save here, and so given that it's an AD environment, we're going to have credentials as it's usually the case with a pen test. So what else can we do? We can configure our hosts file. And I think I had done that already because I was preparing to do this video, but the IP is not the correct one. So, and I think this is going to be the the domain controller, but let's see if that's correct. And so now we can just start enumerating. Let's do first netexec, SMB, this, and then you will put the password and the username. Let's go and do this. Take that into the clipboard as well, so we can use it later. And this guy. And then let's just enumerate that like this. And from there, we'll also get the domain controller. It's a bit slow, but that's okay. And here we have the name of the domain controller, DC01. So that will be dco1.fluffy.hackthebox. So that was correct. Perfect. Now let's look at the shares. And then this we can already copy and go into SMB and put that here, and that will give us some shares. And let's take a screenshot of that right away, because either way we would have started with enumeration in SMB, so we're already well on our way. Let's paste that here. And we can see right away that we have an IT share with read and write permissions. So that's unusual. Well, it might be realistic, but it's unusual in HackTheBox. So this is definitely something we're going to have to investigate. Let's go and see if our recon is done. No, it's still not. So what else can we do? SMBclient. Let's go with SMBclient. Let's do you, because we have a user. And then let's do lists, and let's list all shares. Well, no, actually, we know all the shares that are there. So let's, instead of list, just now let's just list all shares. Like that. Take a screenshot of that and put it there. Then take this and copy that here. There we go. And now we can, with the credentials, enter that share. So IT without listing, and then we copy the password one more time there. Oh, the password with an exclamation mark. There we go. So what we can do here now is do recursive off, recurse off, prompt, no, sorry, recurse on, prompt off, and then mget all, and that will just download everything. And of course, this is not something you'd want to do in a true pen test, but in HackTheBox, it's definitely something we can do. Let's just take a screenshot of this. And here, let's do that. And then before we do the Nmap scans, let's write something. So from our NXC scan that we have an IT share in which we have read, write permissions. Let's begin by entering that share and downloading everything from it. There you go. So we've downloaded everything. Now let's cycle back and just look at the Nmap scans. So here, nothing too interesting. Let's copy it there. Let's take an LDAP scan. And here we have an SSL certificate. And here you can see the certificate, and we have a certificate authority, of course. So that's interesting. Maybe we'll have some Certipy stuff to do later. Let's take the Kerberos Nmap. The DNS Nmap is here. Do we have anything there? Zone transfer. Nope. What else do we have? Evil-Winrm. It's not an Nmap scan, but we still put it there. That. And what else do we have? 445, sorry. Samba. I can remove this from my template actually. I'll do that later. And then we have our PC, which we do like this. And there's quite a few others. I've never really had anything interesting with RPC, but I still write it down just for good measure. And I think that's it. So now we can go ahead and close this enumeration because that's about done. So now we can continue. Oh, let's also take enum for Linux. Like that. And that's about it. So let's continue here. So what did we download? Let's close this and open that folder like this. And here we can see two zip folders, zip archives, and a PDF. Let's look into this PDF first. And let's take a screenshot of this. Like that. We gathered the following 3 files. There we go. Let's look into this PDF. So this PDF is essentially a patch announcement, security advisory for the audience IT department. Okay. And it essentially tells the IT department that some high impact vulnerabilities have been disclosed and that the administrators should be instructed or are instructed to update. So there might be one of these that our target, our environment is vulnerable to. And so let's take a screenshot of this and take some notes. The PDF is interesting because it is a security advisory to the IT department, or from the IT department, which highlights some vulnerabilities that the target environment might be vulnerable to. Let's investigate these. So let's take these one by one and just Google them. PoC, GitHub. Let's see if we find anything for them. Proof of concept. Let's see. This project demonstrates a proof of concept for the CVE, blah, blah, vulnerability affecting Label Studio. Okay, I don't think that's it. Let's go with the next one, because I didn't really see anything to do with Label Studio inside of here. So that's probably not it. Let's take this one. open that, open that, open this. What do we have here? Just all of them? No. NTLM hash leak. This sounds a lot more interesting. Demonstrate the exploitation of the NTLM hash leak via library MS files on unpatched Windows systems. This could be very interesting for us because, like it says here, we can upload something malicious to the share where we have read-write, remember here, and then via responder we can listen back and get a callback or an authentication attempt by Windows. So that might be the vulnerability we're supposed to exploit here. So let's go ahead with that. That one, well no, why did I close that? This is for Metasploit, I'm not interested. Okay, this one looks very clean. Okay, so let's take that one. Let's take screenshots. The following CVE. It looks like it's relevant for us as it describes a vulnerability by which we could leak NTLM hashes by uploading a malicious .raw archive, yes, to an SMB share, and potentially get an authentication attempt back using responder. Let's go ahead and try this. And as we always did in the past, let's do an internal link. And here we can do showcase, fluffy, and then exploit. And then here, let's just go ahead and do this. So I go here into exploits, I clone that repository, and I download this. Then I go inside, and what do we have? We have the PoC. So let's just run that. -- help does that. Okay, no. Exploit. Let's just name it, or not exploit, not malicious. If we listen with a responder, that is probably our IP. And that's it. I would still call it exploit, potentially inside. It says not malicious, it doesn't matter. Let's take a screenshot of this. We can now go ahead and upload this to the share and listen via responder. There we go. So let's open a side pane like this and do sudo responder -i, capital I, turn 0, that's our interface, and listen. And then here we go to SMB, where we have this. No, what am I doing? Let's go back to CVE, and then we do SMBclient -u, our user, Fleischmann, and then the IP address is this one, and then let's go into IT, and then the password for Fleischmann was Joel the Man with an exclamation point. There we go. And then here we can just put the exploit zip data, and then we wait. While we wait, I take some water. That was quick. And we got a bingo. If you know this reference, you're good. We have a bingo. That was such a great. Anyway, we have a bingo. There you go. We have a callback and get an NTLM v2 hash that we can potentially crack using Hashcat. There we go. So let's go ahead and do that. This we can take. Let's close this. And then we can go into loot, hashes, and touch p-Agila. Open it here. Let's close all of this. Hashes, p-Agila, and paste that there. And so now we can do Hashcats. NTLM v2 is 5,600 if I remember correctly. Then p-Agila, then the word list we're going to use. So user share a word list raw queue, and we're going to output as cracked. No, p-Agila cracked .txt, and that's then going to do its magic. Just going to take this command and put it there. And that worked. So that worked. And we should have some new credentials. Let's look at them. Cracked. Yes. So the username is p-Agila and the password is Prometheus X303. Okay, perfect. So let's copy this and put it into loot underneath Flashmon. There you go. And so now, what can we do with these new credentials? We can enumerate again. So let's take this into our clipboard and let's take this into our clipboard. So we do netexec. Usually once I get the next set of credentials, I could have done that right away, but let's just do LDAP, the IP, then -u, Flashmon, -p, then draw out the man with an exclamation mark. Why does it constantly copy it without the exclamation mark? Let me just take this with the exclamation mark. There we go. And then let's do -- BloodHound. And then -c all. And -bns server, I think, is important as well. And let's take all of this, copy it. Is it 2 dashes? Yes, it is. Okay, so let's go back. Now that we have another set of credentials, let's further enumerate. And so here we can take all of this, do an internal link again, and go showcase fluffy internal. And there we go. And these we can do call p-Agila. And then we can say let's capture, let's use LDAP to, now let's take a look at BloodHound. At the environment using BloodHound. And so we can go here to enum, internal. It's called a folder. Let's create a folder called BloodHound. Go inside of it and then copy this. To here. And then we can open BloodHound. By the way, I use the old BloodHound because I don't like the community edition online. There's some functionality that I like that isn't in there, or at least not in the free version, and so I continue using this until I have access to the enterprise version, which I don't know when I'll have, so I'm good with this one. Internal BloodHound, and let's import this. That will do its thing. Clear finished. Yeah, let's just close this. It will do its thing in the background. And then here, what do we have? We have pyWhisker. And that user we have owned. And let's see. Bound object control, group delegated object control. Let's see. It's part of the service account managers, which has GenericAll over service accounts. Very interesting. So we have full control over whoever is in this group, or over this group. Let's see what is in this group. Outbound object control here. And everyone inside of this group has generic rights over each other. So if you are inside of this account, you have generic rights over these. GenericWrite allows you to write credentials, to use a shadow credentials attack, to write an attribute into the msDS-KeyCredentialLink attribute. So essentially you can create shadow credentials into these objects and use those to authenticate via code rows. So that's definitely something we're going to want to do. And so let's see, we can do pathfinding. pyWhisker to, who do we have? WinRM. There we go. And then now we have a path. So let's draw this very nicely. Like this, like that, and like this. So we have a path using, why does it, there you go, using BloodHound, we can see that our pyWhisker user is a member of the service account managers group, which has GenericAll, so full control over the service accounts, which in turn has, so, okay. And members of the service accounts have generic write permission over itself, over themselves. Let's go ahead and exploit these permissions. Let's do an internal link and do showcase fluffy PrivEsk. So we have a path from pyAgila to WinRM. So let's do that. pyAgila to WinRM SVC. So the first thing we can do is exploit this generic all permission. And we can do that using either netrpc. That's essentially you add yourself to this group, or we can use a new tool. Well, it's new for me that I like, that looks cool, and so we can use BloodyAD. Using BloodyAD, and it's quite simple too, I think. Let's go to PrivEsk and let's do that. BloodyAD -- help. And here we can do BloodyAD -u Fleischmann. No, pyAgila -p Prometheus. And then let's do -i as well. Then add, and then group, what is it again? Add group member. And then let's do help again, and it will tell us, and oh. So first the group, so that would be the service accounts. And then who do we want to add to this? So the member, and that will be pyAgila. And that worked flawlessly. Let's close this, and we can close this. Go. There we go. And then we can verify this using netrpc as well. Yeah, there you go. That seems to have worked. Let's verify it did for sure. There you go. So the target group is service accounts. The domain is fluffy.hackthebox. The controlled user is pyAgila. The passwords we used is Prometheus. And the domain controller is dc01 fluffy.hackthebox. There we go. So this should be able to verify that this indeed worked. And it did. There we go. And so now, having done that, we can now exploit the next permission, which is the GenericWrite, using a shadow credentials attack. And that we can also see here, help GenericWrite. The reason I like this BloodHound is because of this help, and it will tell us what to do. So we can either exploit this using targeted curb roast or a shadow credentials attack. And this we will start with pyWhisker. And let's just go on Google and go to shadow credentials attack. There should be an article about it. I think it's this one, which explains very well how this works. I recommend you guys go read it. And then here it talks about the msDS-KeyCredentialLink, and essentially that's where we can write an attribute into it and then use that for client authentication. And yeah, it explains it all here. So let's go ahead and do that. We start with pyWhisker. Let's go ahead and do that. The first step of this is to request a certificate, I believe. Oh no, first we need to populate the KeyCredentialLink attribute. Okay, and we can do that with pyWhisker. Is to populate the msDS-KeyCredentialLink attributes using pyWhisker. And so this we can do here with fluffy.HackTheBox. The controlled user is P Aguila. The password is Prometheus. The target is, that's a target account. So we want to do WinRM as we see. And we want to create a credential for that user. Let's see if that works. Oh, where do I have pyWhisker? Python 3. Let's do Python 3.12. And then that should be in Workspace, Tools, Linux, pyWhisker, and here it is. Now I can paste. There we go. Let's see if that works. Insufficient writes. NetRPC. Oh, okay. There seems to be a script that resets this. There we go. And now it should work. And that did work. Okay. So we need to be conscious of that reset script. So sometimes things might not work and then we've got to reset it. But here we have a password. This is important. The password is this, just so we don't forget that. And now we can go to the next step, which is to acquire the TGT. Sorry. First, we have to unprotect the certificate, because Certipy, we're going to use Certipy, and Certipy cannot handle a certificate with a password, so we have to unprotect it first. So let's go ahead and do that. Next step. The next step is to unprotect the certificate using Certipy, as it cannot handle password protected certificates for authentication, and that will be this command. And so here we can do, I'll just copy it from here. So Certipy, certs, exports, PFX, and then we take the PFX certificate, password, that's the one we just wrote down, and that's this one, yes, and then out we get certificate dot PFX sir. I don't think that is correct. Yeah, that wasn't correct. I don't know where that came from. And this should work. What did I not do here? Why does that not work? Okay, let's do that again. Certipy, cert, help. Then dash exports. Then PFX, and then here we take this PFX, then password. There we put the password, and then out certificate.pfx. That should work. Oh, okay, that did work. There must have been some typo somewhere. Let's take a screenshot of this. There you go. And now we should be able to get the NT hash to authenticate and get a hash. So let's see. We do this will be certificates. The user will be Evil-Winrm as we see, and the domain should be fluffy.hackthebox. This should can't find the targets. Help. Let's do DCIP. DCIP, and let's add let's add the IP of the domain. See if that works. That seems to have done things. Patience, patience. It's slow. We've got a clock skew 2 grades error. Okay, so let's take this. There we go. We get a clock skew 2 grades error, which we can fix using ntp date. There we go. So let's try that. Sudo ntp date, the IP of the machine, and then let's pipe that and do that again. This should work. Still clock skew too great. Okay, let's just try again. That could just be a little bug, because it's definitely, it should be skewing. It should be adapting to our time, to the time of the host. So if that doesn't work still, then let's just try again and again and again until it does, because it should. Because sometimes this can be a bit buggy, you know, and so let's try again. We have time. Yeah, it still says clock skew too great. Right, let's do that alone. There you go. And let's do it like that again. Okay, now it's giving me another error. Let's be... Okay, let's do it like this. Fluffy HackTheBox, because this is the fully qualified name. Client, not in database. Okay, maybe that was wrong. Oh, there you go. That worked. Now it did work. Perfect. So we have the hash for WinRM. Amazing. After some fiddling, we have the hash. There we go. And now we can log it. Actually, there is a way to do this a lot quicker. There is, however, a faster way to do this using Certipy. And that is with this command. WinRM, no, P Aquila at fluffy dot, or let's just do the IP. And then the password would be Prometheus. And then the target account, that would be WinRM SVC. Let's try that. That should work, but let's do also sudo ntp date, and then the IP pipe, and then let's do set by shadow, because that does it automatically. Maybe that will work. Insufficient access. Okay. Why did that not work? Like that? That was the exact same command. Anyway, it doesn't matter. I'm trying to get the ticket granting ticket. Okay, so clock skew error. Okay. Now it's a different error. Let's just try again. Yeah, this is all a bit buggy. Okay, that doesn't work. Anyway, let's connect. Evil-Winrm -I the IP. And then -u WinRM SVC -p, no -h. Like that, and that should be it. But that doesn't work. Let's go ahead and log in as Winrm as we see. And here internal, we can do another note and then go create a link to showcase fluffy internal untitled. There we go. And then here we can do Winrm SVC. There we go. And then here we can go back, go to the desktop, and there we have our flag. We have the first flag. And so now, what am I? Priv? Okay, not really anything here. Is there a web server? Oh, something we can do is that before we had a CA SVC and we had LDAP with SSL, so certificates. So maybe let's go that out here. Let's remember that we have another user called CA SVC. So let's see if there is a certificate authority and a potential misconfiguration of that server using Certipy. So these would be the ESC vulnerabilities. So how do we go about this? So first we need to gather the hash of SVC, CA SVC. So let's add ourselves to the group again. Okay, we still are. Then let's get the there you go. Let's get the populate the msDS-Credential attribute for CA SVC. By the way, this is this. Yeah. Let's first get that user's hash. So add, and then we have the password here. And then we have to do the unprotection. And there the password is this, and then here we have this, and then out we get certificate CA. That worked. There you go, and then we can authenticate. We can authenticate to CA SVC, but not with this, but with this. And that will not be this certificate, but the CA certificate. And here we want to connect as CA SVC. That should work. Skew too great. Skew too great. This is a bit annoying. And there we go. We now have the hash of CA-SVC. Let's put this into loots. There we go. And so now what we can do is first we need to get the name of, okay, let's just do this. We need to get the name of the certificate authority. So that will be the IP, the user CA-SVC-help. How do you put in hashes in netexec? I forgot. Username hash h then the NTLM hash -m ADCS. There we go. Let's take a screenshot of this. Why does it keep doing this? There we go. And this is the CA authority. And now we need to do Certipy find -u CA-SVC passwords. I think here it's hashes. Yes. Hashes, and then we take the entire hash, and then we do standard output and vulnerable. There you go. The targets. Let's do DCIP. If it is DCIP, yes, it is. Do we have any vulnerable configurations? We do. Okay, so we have, let's do this like that. Certificate authorities, let's take all of this and then let's do a box around vulnerabilities like this. And here we have found our path to roots. We have a misconfiguration known as ESC16, in which a security extension is disabled. Extension is disabled. Oh, okay. Disabled extension is this one. And there is, I'm thinking, probably a article around that, ESC16 exploits, that will show us how to exploit this. And this is the official one, and this is the Medium article. Okay, so here it explains exactly how that works, and here how to exploit it. And I'm guessing here it's the same. Okay, I'll put both of these in the description if you want to know exactly how this works, but let's just go ahead and do it. Okay, so let's understand at least a tiny bit what's going on here. ESC16 describes a misconfiguration where the certificate authority itself is globally configured to disable the inclusion of this security extension in all certificates it issues. This SID extension, introduced with the May 2022 security update, is vital for strong certificate mapping, enabling DCs to reliably map a certificate to a user or computer account's SID for authentication. So essentially, if that security extension is disabled, then we have a problem. More on that you will find in this article. Let's go ahead and exploit this. Let's exploit this. Here we can do an internal link again, and then we can go to PrivEsk and create an untitled one. Go back, go showcase, fluffy, PrivEsk, titles, and then we can do CA SVC to, and then we can exploit or escalate our privileges using the ESC16 misconfiguration in how many steps? 1, 2, 3, 4, and 5. 5. In 5 steps. Step 1. Read the initial UPN of the victim account. Okay, so first to read it. Okay, I see. And that would be, who are we attacking? Let's do this using Winrm SVC's user. Let's do my fluffy HackTheBox. The password will be, oh no, let's do P Aguilar, because there we have a normal password. And that was Prometheus. Then the DCIP is this, and then our victim will be CA SVC. And then let's read. There we go. So here we can see that the attribute inside of CA SVC, we've got the user principal name is a CA SVC at Fluffy. Okay. And the service principal name is ADCS. So it has some sort of, it's the certificate publisher of the certificate authority. We should be able to see that here. CA. What groups is that part of? First degree object control, no. Why is it not? There we go. So he is in first degree group memberships, domain users, service accounts, and cert publishers. That's the interesting one. If you are part of cert publishers, you can manage some things in the certificate authority. So we can read that. And there we go. And step 2 is to update the victim's UPN. And that we're going to do using Certipy as well. So here we do Piagilla, Prometheus, like before. Like that, the DCIP like that. And then instead of reading, we're going to update the victim, and that will be, no, here we're going to do user administrator. And then the victim we're going to update is CA SVC. I believe that should be correct. Or maybe it's the other way around. CA SVC and then user administrator. No, it was the other way around. No changes specified for updating user victim. Oh, UPN. Did I not? Oh, I didn't copy the correct one. My bad. So here it shouldn't say a user, it should say UPN. And there it should say user and then the victim update. There you go. I didn't copy that correctly. There we go. And that worked too. Let's take a screenshot of this as well. Because essentially what we can do now is read this again and it will show us something else. And here you will see, okay, that didn't work. Update. Oh, it doesn't have permissions. Okay, so let's go back. BloodHound, BloodyAD. There we go. There we go. And then let's update. There we go. This is the screenshot we should have taken. I didn't actually look at the text. It did say doesn't have the permissions, so I should look. There we go. And then now if I read, there we go. Now it says user principal name administrator. So for now, everything's going very well. And we can verify that this worked by reading the UPN. There you go. And then the next step is to obtain the credentials. Can I now already request the hash? Let's see. Will that work? Let's see. Oh, that was what we did before. Of course, but that didn't work. Let's do sudo ntp date, but that didn't work. So let's see. Let's see what this guy here says. Step 3 is to request. Oh, but here it requests differently. Okay, so here. So if needed, obtain the credentials for the victim via shadow credentials. We did that before. We don't need to do that now. Is that the same here? Yeah, it is. So let's just do the request. Step 4. Request the certificate of the victim. And that will be not via K. Okay, not via Kerberos, but let's do it this way. DCIP. Then for CA SVC. No, not CA SVC. There you go. Targets, that will be Fluffy. So HackTheBox. Let's do here the IP. And then the ADCS. We need the certificate authority, that is Fluffy DC01-CA. And then template user. Requesting certificate via RPC. No route to host. Let's take this away. BloodyAD. Let's do CA SVC. What am I doing here? CA SVC at help, maybe with ashes. No road to host. Help. DNS ADCS. Why does it say no road to host? Is that just buggy or? Okay, let's see. Okay, so this worked. All right. Okay, and so now we can replace this with that. And so now we have the administrator certificate. And now step 4 is to revert the change. By resetting everything back to how it was. So here we're going to do Yagila. And then the targets will be Fluffy HackTheBox. Essentially, that's just what we did up here. And then here we'll do it back to CASVC. There you go, that worked. And then the final step is to authenticate using the stolen certificate. And with that, we're going to get a hash for that user. So the domain will be Fluffy Box. The IP will be this. And so let's see if this works. Skew to great. Okay, sudo ntp date. Let's see. Skew to great. Let's try again. And it worked. And with that, we have gathered the administrator hash. We have a bingo. And we've gathered the administrator hash. Once. And we can now log in using Evil-Winrm. WinRM WinRM-I VIP -U administrator -H the hash. And bingo, we are root, and we can go and get the second flag. And that, ladies and gentlemen, with a bit of fiddling, was Fluffy. Thank you guys for watching. I hope you guys enjoyed it. please like and subscribe. Yeah, especially subscribe if you want to see the remaining machines that will come. I'll try and be consistent now and bring out, I think, 2 machines per week. And yeah, that will be 8 weeks and I'll be through the track, and that looks like it's a good idea to do. Anyway, thank you guys, and I'll see you guys in the next one. Peace.